So I'm going to start this off by describing the three parts of the nervous system, okay? We talked about the autonomic nervous system. What's another word for autonomic nervous system? Involuntary, involuntary. Make sure you know what that means, right? We're not voluntarily controlling our autonomic nervous system. Our somatic is also called our voluntary, okay? We talked about that extensively. Let's talk about what's happening in the spinal cord. Excuse my scratchy drawings, kind of rushing here. Okay. All right, let's talk about what's happening in the spinal cord in each of these areas. So first, let's do sympathetic. We know the autonomic has two divisions, the sympathetic, the parasympathetic. Okay, and I won't go into the function, but you should definitely know the functions of these two divisions. What kind of body functions do we see with sympathetic? Increased heart rate, right? Decreased digestion, those types of things. Skeletal muscle movement. What kinds of function do we see with parasympathetic? Rest and digest, glandular secretions, things of that nature. So make sure you know the different functions under the different divisions. And then we know that the somatic nervous system is pretty much simple. This is skeletal muscle. Okay, let's speak about the two neurons that are involved here. So we know that in the sympathetic system, is there a longer or a shorter preganglionic neuron? Sympathetic system has a longer or shorter preganglionic? Shorter preganglionic, right? And then a longer postganglionic. In the parasympathetic system, we said there was a long preganglionic and then a short postganglionic. And then in skeletal muscle, how many neurons do we have? Just one motor neuron, okay? Let's describe our effector tissues really quick. So in autonomic nervous system, what are effector types of tissues here? Not skeletal, adipose, glands, smooth muscle, cardiac muscle. Good. So adipose, glands, smooth muscle, cardiac muscle. Okay, these are our two types of effector tissue. Here we already said skeletal muscle. Okay, the somatic is only skeletal muscle, only muscle that we can voluntarily control. All right, let's speak about, let's label these off here. You know, this is called the postganglionic, oops. And this is our motor neuron. Let's speak about receptors and neurotransmitters. So on the junction here, what type of receptors what type of neurotransmitters released from preganglionic neurons? Always acetylcholine, always acetylcholine. We know in the somatic system, it's only acetylcholine, okay? What type of receptor do we see on the postganglionic neurons? They're cholinergic, but specifically nicotinic, right? So we got a nicotinic here. We got a nicotinic here. We know this is going to be also a nicotinic. What type of neurotransmitter does this second neuron release, the postganglionic neuron here? Sympathetic side. Norepinephrine or epinephrine, okay? So our neurotransmitter released here is norepinephrine or epinephrine. What type of receptors are going to bind to here? Norepinephrine or epinephrine binds to what type of receptor? Adrenergic. I think I'm hearing it. Adrenergic, right? Adrenergic. And this can be what? What does adrenergic mean? What are the types of adrenergic? What are the types of adrenergic? We got our alpha 1, alpha 2, beta 1, beta 2, beta 3. Make sure you know the affinities for these receptors, what tissues they're found on, what second messengers they excite. Please review that, okay? Please review that. What affinities they have, whether they prefer epinephrine or norepinephrine, what tissues they're found on, and then what their second messenger does. Let's look here. Our second neuron in the postsympathetic, on the parasympathetic side, releases what neurotransmitter? We know it's not norepinephrine. Acetylcholine. Good. So it's going to also be acetylcholine. What type of receptors are going to bind to here in our smooth muscle, cardiac muscle, adipose, or gland? A muscarinic receptor. So it's cholinergic, but it's a different type of cholinergic. What's the difference between a muscarinic and a nicotinic receptor? In one word. Metabotropic or inotropic. Yep, that's right. And then more simply put, fast versus slow, right? Which one is slow? Metabotropic, right? So our muscarinic receptors, which are here, are example of metabotropic, which are slow receptors, okay? Let's speak about the areas of the spinal cord. I kind of skipped over that. So where do the fibers of these various nerves arise? The sympathetic and parasympathetic to start. Sympathetic is T1 to L2, parasympathetic. Cranial nerves, which ones? 3, 7, 9, 10, S2, right? Sacral nerves, 2, 2S, 4, S2, S3, S4. What part of the spinal cord do they arise from? What horn? Lateral horn, right? Lateral horn. What about the somatic nervous system? What part of the spinal cord does this arise from? The ventral horn, right? The ventral horn, good. So lateral horn, ventral horn. Now, where do they exit the spinal cord? So not the horn, but what root? They all exit through the ventral root. So they're all coming out through the ventral root here, okay? Please make that distinction. Make sure you also know when it's myelinated. So when it's white ramus, when is it white ramus? When it's exiting. So the preganglionic neuron is white ramus, so it's myelinated, and then the postganglionic fiber is gray ramus, so it becomes unmyelinated, okay? Make sure you review that. The last thing I'll talk about here are the 3 routes of communication. So this is a sympathetic ganglia, right? Specifically for the sympathetic system. And what does this form in the body? What does this line up to form? The sympathetic chain, perfect. I'm hearing it back there. So this is lining up to form the sympathetic chain. But that is only one route of communication for the sympathetic nervous system. What are the other 2 routes? I think I'm hearing it loosely in the back. There were 2 other routes of communication. We could synapse onto a ganglia that is not a part of the sympathetic chain, so we called it a collateral ganglia, right? And then we could synapse onto adrenal chromaffin cell, right, in the medulla. Adrenal medulla chromaffin cell. Okay, so these are our 3 routes of communication for the sympathetic nervous system. I think that's pretty much it. Any specific questions for the nervous system? Anything else that's confusing or didn't make sense? Now, in terms of just understanding terminology, we call this junction here the neuroeffector junction, and then we call this junction the neuromuscular junction, okay? So this is the neuromuscular junction, whereas this was the neuroeffector junction, right? Both of these. What is the difference between the neuroeffector junction and a traditional neuron-to-neuron synapse? What's the difference here versus here? There were two differences that we mentioned. The presence of something. Not vesicles, something that has the vesicles. Varicosities, right? We have these varicosities, which are these swellings along the nerve terminal, okay? And then there was a second difference that we talked about. A second difference between our neuroeffector junction with varicosities and a neuron-to-neuron synapse. The greater distance, right? There's a greater distance here. So we have a greater distance here than we do here, okay? And I think that's it. I can't think of anything else that we talked about here. Any questions? Any questions specific? Make sure you review your receptors. I'm not going to go into the receptors, but make sure you create a table that looks something like this as a review, okay, where you list out the tissue in question, you list out the receptor, you list out what its affinity is, whether it prefers epinephrine or norepinephrine, and then you list out its second messenger action and its effector tissue action, okay? That's a really good study table to help you kind of synthesize that. Any other questions? Any questions? Sure. So here we were mentioning, and I don't have that. Here we mentioned that basically there's no lateral horn. So there's no lateral root, right? The root is where these fibers are actually leaving the spinal cord. So the horn is in the spinal cord, but how do they leave the spinal cord and become a part of that spinal nerve? It's either the ventral root or the dorsal root. There's no lateral root. So although fibers are arising from the lateral horn, they have to use the ventral root as a route to get into the spinal nerve, okay? So autonomic fibers come from the lateral horn, exit via the ventral root. Somatic fibers come from the ventral horn and also exit via the ventral root, okay? We spoke about the dorsal horn, which is where the sensory fibers are coming in. We talked about that mixed composition of the nerves. So there are two directions of travel. There's information coming from sensory organs to the CNS. They're going into the dorsal root. Information going from our CNS out to our effector organs comes out the ventral root, okay? I hope that made a little sense. Any other questions? Okay, and then the last thing I'll touch on, and just a reminder rather than to review, make sure you review this table. We drew this out in class, so you should have this. And this is basically that flow for the endocrine system. For the endocrine system, you want to know the flow here. We talked specifically about thyroid hormone and specifically about the adrenal gland, the 3 hormones of the adrenal cortex, okay? Make sure you review that.